Hi everyone, today you're going to be taking some notes over the second section of chapter 2. This one is on solving systems of linear equations. Again, this is something that you have done before in Algebra 2, so nothing really new, but just again a nice refresher. So remember that before we could write equations and define everything in terms of one single variable. But now we're going to be talking about writing a system of equations where we can actually have two variables and we're going to be able to solve for both of those variables. So let's just have a little introduction to that. A system of equations is of the form ax plus by equals h and cx plus dy equals k. So basically we have two variables here. We have x as a variable, we have y as a variable. A, b, c, d, h, and k are all numbers, real numbers in this case. Okay. Also, a solution to a system is an ordered pair that is a solution for both equations. So since we're talking specifically about a system of linear equations indicates that if we were to graph each of these, that we would get a line out of them. And so a solution to the system is an ordered pair that is a solution for both equations, or if we were thinking about this in relationship to a graph, if I have two lines that I have graphed, it's going to be the ordered pair where those lines would meet one another. Okay? Now, we're going to talk really about two methods for solving systems. In Algebra 2, you learned about three different methods, and one of the methods was actually to graph the two lines and to see where they intersect each other. And graphing is not a bad way to solve them. However, it's not very precise. If you don't use graph paper, if you don't use a straight edge or something like that, it can sometimes be tricky, especially if you're having to estimate where fractions or decimals are. So it's really better to use one of the other two methods that we have for solving a system. And we're going to talk about each of those now. Okay. So the first method, let's say methods for solving. We'll call this one number 1, is substitution. And the substitution method is a nice one to use if you have one of the equations that has a variable with a coefficient of 1, then substitution might be a good method to use and might not be too bad. So let's walk through an example of that. If we have 2x minus 3y equals 7 and 3x minus y equals 7. So in this case, we have two equations. We've got our two variables x and y, and we have one of the variables in one of the equations that has a coefficient of 1 or negative 1. And so that's actually going to be really nice. So what we're going to do here is solve 3x minus y equals 7 for y. Basically, we want to try to get y by itself. Okay. I'll do that in a couple of different ways. I'm probably going to add y to both sides so that I have 3x equals 7 plus y. But I need to get y by itself, so I'll subtract 7. So 3x minus 7 is equal to y. Okay. Now I'm going to take this new equation that I have And I'm going to go back to the other equation, this 2x minus 3y equals 7. And in place of y, I'm going to substitute 3x minus 7. So that it's going to look like this. 2x minus 3 times 3x minus 7 equals 7. And now this becomes a pretty straightforward linear equation like we solved in the last section to be able to solve. So let's proceed with that. So 2x minus 9x as I distribute here, and then plus 21 as I distribute negative 3 and negative 7 equals 7. Or negative 7x plus 21 equals 7. I'll subtract 21. So negative 7x is equal to negative 14. And then finally, divide both sides by negative 7. So x is positive 2. Now, this is not the entire answer to our problem. Remember, we're needing to find an ordered pair, and an ordered pair is going to consist of an x value and a y value. However, now that I know the x value, I can take that x value and substitute it back into either one of the original equations, and I can find out what y is. And again, it doesn't really matter which one you use. So in this case, I will probably substitute it back into the second equation. So I'm going to just have to make some space here. There we go. So I'm going to have 3 times 2 minus y equals 7, or 6 minus y equals 7. Subtract 6 on both sides, so negative y equals 1, or y equals negative 1. So we have now found that x equals 2, y equals negative 1. So the solution to our system, which we said was an ordered pair, is going to be the point 2, negative 1. Okay? And that is how we use substitution to solve a system of equations. Again, this should be pretty straightforward in review for you, so hopefully this was a good refresher. Okay? All right, we have another method that we use, and you may have heard it called a couple of different things, but for our purposes, we're going to call this method elimination. And in elimination, our goal is going to be to manipulate the equations so that we can eliminate one of the variables and solve for the other variable. So again, let's just start by looking at an example. X minus y is equal to 3, and x plus 2y is equal to negative 3. And our goal here is going to be to try and get the coefficients on x to be opposites. Remember that opposites means one positive and one negative. Or the coefficients on y to be opposites, so that I can add these equations together and get one of the variables to go away. So I can pretty easily do that by noticing that I already have a negative y here and I have a positive 2y here. So what I'm going to do is, and I'm going to write what I'm going to do, so multiply the first equation by 2. Okay, and the way that I show this sometimes is I might write the equation x minus y equals 3, and I'm going to put just a little times 2 up here, and I'm going to go ahead and make a new equation. 2x minus 2y is equal to 3. Okay, new equation. Okay. Now, in order to solve, I'm going to take the new equation that I have, and I'm going to take the other equation that I have not changed, and I'm going to add those two together. So I'll have 2x minus 2y equals 3. That's the first one. Or no, it's not 3. Ooh. Should be 6, right? 2 times x, 2 times y, and 2 times 3. Okay. And lastly, I need to take the other equation, x plus 2y equals -3. And we're going to add those together. Notice that I stacked them up nicely so that we can see what's happening. So it's going to be 2x plus 1x, which is 3x. -2y plus 2y is 0, which is exactly what we wanted to have happen. So we eliminated the variable y. 6 plus -3 is 3. Then we can divide both sides by 3 so that x is equal to 1. Now, in the same way, we are not finished yet because we have not found the ordered pair that is the solution. We've only found the x value. This is where the two methods now become the same. Once I know one of them, I take it and I put it back into the one of the original equations, and we solve for y in this case. So it doesn't really matter what we do. I might use the second one in this case. So 1 plus 2y is equal to -3. Subtract 1 on both sides. So 2y is equal to -4. And divide both sides by 2 so that y is equal to -2. And then again, we're going to write our answer as an ordered pair. X is 1, y is -2, and there we have our answer to this particular problem. Okay. Okay, I want to show you just a couple of things real quick that you might run into as you're solving problems today using one of these methods. And this should not be really a big surprise based on what we talked about the other day. So if we have something like x plus 3y is equal to 4, and 2x plus 6y is equal to 7, and we want to try and solve this one, I could see either using either substitution or elimination on this one. Let's use substitution on this one. We'll use elimination on the next one. That way you can kind of see a different approach. So I'm going to take the first equation, x plus 3y equals 4, and I'm going to solve it for x. Okay, again, because it has a coefficient of 1, that's going to make it easy to solve. Okay, I'll do that simply by subtracting 3y. So x is equal to 4 minus 3y. Okay. Now, again, once I have that, I go back to the other equation, this 2x plus 6y equals 7. And the place where I have an x, I'm going to now substitute. So I'm going to have 2 times 4 minus 3y plus 6y equals 7. Or we end up with 8 minus 6y plus 6y equals 7. And hopefully you can see something now that is going to be interesting. And that is, when we combine these like terms here, -6y plus 6y is 0. And I end up with 8 equals 7. And we talked about this in the last section, that when we solve equations, and the same is true when we solve systems of equations, if you end up with a statement, the variables are all gone, and you end with a statement that is untrue. Okay, so remember we said this one was untrue. Then this actually has no solution. It cannot be solved. So if we think about what that means when we're talking about solving systems, remember that we said the solution of a system is where 2 lines intersect each other. So if 2 lines do not intersect each other or have no solution, they don't intersect each other, which means we're talking about a system of parallel lines. So lines that have the same slope but different y-intercepts. Okay, so that's one scenario that you might run into today. I want to talk to you about the other one so we can see what that looks like. And this time we'll use elimination to solve to make that nice. So similar equation, x plus 3y equals 4, 2x plus 6y equals 8. Okay. So in this case, I need, again, to try and, if I'm using elimination, get one of the variables, either the x or the y, to have coefficients that are opposites, meaning, again, one positive and one that's negative. And it's pretty easy to do if you have one that has a coefficient of 1, because in order to make this the opposite of 2, I just need to multiply it by negative 2. So I'm going to multiply the first equation by negative 2. And when we do that, we get negative 2x minus 6y. Negative 2 times 4 is negative 8. Okay. And I'm going to take then my new equation, which was made from the first one, and I'm going to take the second equation now and write that below it, and we're going to add those two together. And what ends up happening here is that I get negative 2x plus 2x is 0, negative 6y plus 6y is 0, negative 8 plus 8 is 0. And so what we find here is that we have something that is always true, right? 0 always equals 0 and always will equal 0. And so what we have is infinitely many solutions. Okay. Now, what does that mean? So we said that, again, the solutions will be where the lines intersect. Well, this one has infinitely many solutions, indicating that what we have is a line and the exact same line over the top of it, okay? So that these two equations, if we were to graph both of them, would be the exact same line. And so you can see that they're overlapping at every single point. And how many points are on a line? Infinitely many. Okay, so that's what I have for you as far as solving systems of equations. You can now get back into Canvas and see what the assignment is for this lesson. Okay? All right, have a great day. See you guys soon.